Our next presenter is Vertriest. He's a supervisor of field gemology based in GIA, Thailand. His job today will be, in fact, to explain GIA's field gemology program. So, Vim.
Thanks. All right. Well, thank you for welcoming me here, and it's great that everyone's still here after such long days of intensive learning and studying. I'm supervisor of the field gemology department, which is a very young department at GIA. I think we've been around for less than a decade, and it's still a department that's shrouded in a lot of mystery. There's a lot of information that came out, but very few people know actually who we are, what we do, and why we do it. So that's why I'm here to explain a little bit more about that. So first of all, gemological laboratories. Why are they here? Gemological laboratories are here to answer questions from the trade. You people from the trade come to labs and ask us different questions. One of the first questions was probably, what is it? So that is basic identification. Is this a ruby or is it not? Then, as all gemological laboratories evolved, the second question was, is this real? Is my stone a synthetic or is it an imitation? So that's a very important question. And I think now in the last years we've seen another question come up. Where is it from? Which means origin became much more important. Why that is? There's a lot of different reasons. I think one of the main reasons would be marketing and auction houses. Auction houses in the last years have really put a premium label on certain origins and really branding that towards the public. So people see it in all these expensive gemstones that go out on the posters, that these are branded as cashmere, sapphire, Burmese rubies. So if you want the best for your wife as an engagement ring or as a present, you want that best quality. So you want a cashmere sapphire. Another thing is, as discussed a lot of times, is transparency and the supply chain. People care about where the material comes from, so origin determination plays a big role in that as well. And then just the general public awareness. I think one of my examples that I can use is the enormously well-written book, Ruby and Sapphire by Richard Hughes, where he has a chapter on judging quality, connoisseurship in sapphire and ruby, where he discusses all ruby and sapphires based on origin. With all respect for Richard, he has put a disclaimer, but it's 2018. I would remind everyone, when was the last time you read a disclaimer? So we try to take a scientific approach. We have heard a lot of great science already, and it takes a few different things. One of the first things is qualified, experienced staff. I think with plenty of those people around, there's a lot of postdocs, PhDs, people with more than 40 years of experience that are working in GIA's laboratories on research. So that's already a great thing. The second thing is advanced instruments. We've learned a lot about new techniques that are being used. So those are really critical if you want to work more on origin determination in a serious way rather than go on gut feeling. But then most important of all, and I cannot stress this enough, is reliable samples. You can have the best scientists in the world with the most advanced equipment. If you don't have any good samples to work on, all the work you do is by default useless. So that is what the field gemology department focuses on these reliable samples, especially for origin determination, getting a sample that comes from someone who says it's from somewhere else, who got it from a neighbor, who got it from his aunt who has ever been to Afghanistan, doesn't mean that that ruby is from Afghanistan. So reliable samples, there's a quote that I really like from David Attenborough, who is still much more respected than I am. So I'm just going to use that quote. A research library associated with collections is almost of greater importance than the objects themselves. Unless you know where it came from exactly, and when it came from exactly, you're missing a lot of very, very important information. And that information can not only come from the object itself, so in our case the gemstones, but from the circumstances of documentation that should accompany every scientifically collected specimen. This means that a reliable collection is more than a drawer full of stones. There is a lot of work that goes into documenting all these stones and collecting all this data. So that's a beautiful theory already. Now at GIA, how do we put this field gemology program in real life? How do we make these reliable collections in real life? So first thing we do is going where the stones are. That means a lot of things. You can get stones at the mine, but you can also get reliable samples in other places. For example, the Tucson Gem Show and all the stages in between. But it's important that you know all this information. So going where the stones are is particularly important. How do we store all this information about where our stones are from? So that gives an indication of how reliable are our samples actually, because we can all feel that a sample bought from a third party in the Tucson Gem Show is a little less reliable, but not less valuable than a stone that was collected by myself when I go to the mine, hit a rock there, and take a 10-carat ruby out. That's still hypothetical up till now, but I'm aiming for that nonetheless. So we classify all our samples by collecting all this information. So we have information about the stones, about the locations, GPS coordinates, of buying locations, but also of collecting locations, because we don't always get the stones where they came out of the ground. And then the buying conditions. Buying conditions are probably most critical. So buying conditions, we give it an A-type sample when it is mined by the gemologist. So GIA sends teams into the mine, and this is sampling pink sapphire and rubies in Greenland. So we take it out of the rock ourselves. We're very sure of this origin. Another option is what we call a B-type. That means that a gemologist witnessed the mining. I hope that most of you had the opportunity to visit a mine, but most miners rather have that you touch their daughters than that you touch their gemstones. So it's really hard to actually get permission to go into the mine and collect yourself. You are able to witness, so we call this B-type. This is an example from Chanthaburi in eastern Thailand, where we were able to witness the miners cleaning the jig and taking the gemstones, in this case mainly black star sapphires and blue sapphires, out of there. Another type is C-type, which means we still collect it at the mine, but we don't witness the mining. This is an example of rubies that were mined in Mozambique at the Gemfields mine there, where we were able to collect material that has never left the mine site, but we didn't see them come out of the ground, or we didn't see them being mined or being washed. So they were just stored at the sort house. Another example is D-type, that we collect them from the miner, but not at the mine. Not every miner stays 24 hours on site. Those guys also go home after work. So this is an example where we met a miner in the Mogok Valley who was driving home his motorcycle, but he still had some stones in his pocket and was willing to sell them to us. Then another example is E-type, where we buy it from a secondary source, usually a dealer, close to the mines. So this is an example from Cobalt Spinel that we were buying in Vietnam from this family business. She drove a very hard bargain, by the way. But these are samples that we still collect, although we haven't collected them in the mine ourselves. They still have a huge scientific importance, because usually the quality gets a lot better the further you go from the mine. And then last of all, we have F-type, that is collected from a secondary source in the international market. Everyone who has experience in colored stones probably know that the easiest place to find Madagascar sapphires is actually Sri Lanka. So these are Madagascar sapphires that we collected in Sri Lanka, but that is very far away from the source. The chance of making mistakes in origin there are huge compared to collecting at the mine, but this is sometimes the only option you have. For example, if you want to study a deposit fast, you need to work with the material you have on hand. A good example is Ethiopian emeralds. Ethiopian emeralds showed up in the trade. I was able to collect them in the trade, but we only were able to collect A-type, B-type, C-type material a year and a half later. That doesn't mean that all this research can wait for a year and a half, because these stones are actively going to the trade and coming in the lab. So we work with what we have, but we still record all that data, and we put more confidence in our A, B, C data than we do in our F and E data. So the life of a research sample. We've seen all this amazing research being done, but there's a lot of work that goes into it actually. So there is, this arrow moved a little bit, but this is a picture I took in the Ethiopian emerald mines, where you can see that there's a tiny crystal in my hand. So this is a crystal that I picked up from the rock myself, so that we would classify this as an A-type sample. This is what it looks like. So I made all the field notes on it, recorded the names, the locations, GPS localities, gave it the A-type code, who collected it, where it was collected, the price, what other minerals are associated with it. So this whole parcel was collected right there. So we're looking at this small piece here. Then we managed to get it to the GIA lab where it gets stored. So it gets a unique number. It gets a list of data that should be collected. Right now, many more of these boxes are ticked. And we copy all of that information again on the physical cassette. Here in the back, you can see the stone, and it has its unique barcode on the bag there as well. The stone goes in a database. This is what our database looks like for the moment. So all this information is available to all GIA gemologists across the globe. So they can access all the data collected on this stone and have an idea where is this from and how reliable is this data with regards to origin. And of course, if you take a rough stone out of the ground, there's not a lot you can do with it. For most analysis, you need to prepare your stone. So that is what we do here, where we actually facet the stone, put a few windows on it, so we can look at all the inclusions. And this is an example of one of the inclusions we saw in this small stone. So here we can really see a cool inclusion where you can see that the emerald stopped growing, some matrix formed around it, but in that matrix, a second small emerald grew. So I think this is a really neat example of really cool observations you can do in all these samples that we collect at the mine. And then, of course, we do more than inclusion photography. So this black triangle over here is the small emerald that I collected in the mine that is now integrated in GIA discrimination plots using trace element chemistry. That is currently being used in production to determine origin of emeralds that come into the lab. So you see there's a lot that happens to these stones before they're actually used and turned into data for our production. So going from that small rock I picked up in the mine to this small triangle here, it's quite an impressive lifespan already for such a small research sample. So our GIA colored stone research collection is mainly based in Bangkok, and right now it's a unique collection. There's no other lab that has something like this, that is the collection that is so well documented, because we have collected all this information, where it's from, who collected, what the price was, what's the name of the miner, sometimes even what the guy was wearing, because we have a lot of samples that have yellow hat miner, because the miner always wears a yellow hat in Thailand, and we don't know how to pronounce his name correctly. But that collection at the moment comprises more than 20,000 samples that are more than 1 million carat in total, that is uniquely dedicated to research. That research is more than origin determination. It is also used for treatment experiments, because right now those are more really good for origin-specific heat treatments as well. Like certain treatments are only done on certain stone varieties. Certain stone varieties means stones from certain localities. And this collection was built up over 90 expeditions. I think the first expedition was 10 years ago. The last expedition was last September, so 3.5 weeks ago. So the focus is, of course, on ruby, sapphire, and emeralds. That is what we offer most of our origin reports on. So we do all this to support origin determination. I would love to go to the field just to go to the field, because I love being there. But we do always have the reason that we support research with it. So that is why the focus is on rubies, sapphires, and emeralds. We focus on recent deposits. For example, Mozambican ruby, only been around for 10 years. Madagascar material, been around for maybe 2 decades. Ethiopian material, been around for less than 2 years. But also on established deposits. Mogok mining has been documented there for more than 1,000 years. It is still extremely valuable to go there and keep going there, because there are always new things coming out, new pits being mined. So you want to get as much data as you can, as much samples as you can, to see all the variation within one deposit. So these are the places where we have done all our expeditions. You can see that all the dots shifted again. I have no idea how that happened. But most of the concentration is in Eastern Africa and in Asia. So you can see that Eastern Africa has been very heavily focused. A lot of the ruby and sapphire deposits in the last 20 years were actually discovered there, and they are very challenging for origin determination. Also, the more classic East Asian deposits, for example, the Burmese rubies or the Thai Cambodian ruby deposits, although those Thai Cambodian ruby deposits aren't producing much material anymore, we still go and visit those because those stones, as we've learned in the last talk, they don't go away. They're still in the trade. There are stones in the trade that have been mined 400 years ago, and they're still being passed on from mother to daughter, and those might show up in our lab. So it's important to keep visiting these established, even finished deposits, although a deposit is never truly finished, and there are people still mining rubies right now on the border between Thailand and Cambodia. So as a conclusion, I would say that origin determination, whether we like it or not, or whatever reason it is an important aspect of the trade. One of the best examples that I had was in the last few days, I talked with a couple of people and I asked their opinion about origin determination. They always said, we don't really care about it. We care whether the stone is beautiful or not. 2 minutes later, somebody brings out the stone and the first question they ask is, where's this from? So we need to do some introspective thinking about that as well. Then origin determination is incredibly complex. We've seen a lot of talks that touched on that, going from photoluminescence to blockchain technology to trace element analysis. So all of that is required to do proper origin determination, together with a lot of experience that is already present, but also, and most importantly, you need reliable samples to do all these studies on. And then lastly, I would like to leave you with this image. This is a photo I took 1.5 years ago from a sapphire mine in Kanchanaburi. As you can see, Kanchanaburi is in western Thailand, and it used to be the biggest sapphire producer in the 80s and early 90s. Later than the 90s, I couldn't find any references to this deposit except for saying that it is completely finished, extinguished, and that not a single stone is coming out of there. This is a photo taken 1.5 years ago. You can clearly see that there's a lot going on there. This is actually the largest single sapphire mine that I have observed in my whole life. So I think if there's one thing I want to leave you with for this whole talk, it would be, if you don't go, you don't know. Thank you very much for your attention. If you have any questions.
Any questions for Wim?
You said that the colored gemstone research collection is available to the public?
It is not. Not yet at the moment. There are plans that is maybe going to be shared within academic circles first, but right now that is limited to GIA researchers, although those researchers are spread across the globe in colored stone laboratories in Carlsbad, New York, Hong Kong, Tokyo, and Bangkok. Yes? Oh, she's running away with the microphone. Oh, there's someone else here.
If you have a corundum that's, let's say, a color change that you've never seen before and you haven't been able to find any information on it except for one book in the 80s, what's the best resource that you can go about finding any more information about it? Because, like, you know where the stone is from, but when you look on Google, Google's not very good at telling you anything about gemstones that most people don't know about.
So the question is, which sources do we use for our information?
Like, what source could I use as a person? Like, let's say, as a GG, I've found a stone that color changes unlike anything I've ever seen before in a corundum. What can I go about doing to find out where they come from or where more of them are? Or?
I think, as I've said, origin determination is incredibly complex. It is probably one of the hardest things we do in gemstone laboratories right now, and it requires a vast range of techniques. That goes from the classic inclusion analysis, combined with spectroscopic methods, combined with trace element chemistry. I think that a lot of, especially since you're addressing more challenging cases, this is not house, kitchen, garden gemology.
Right. It's hard to figure out the price of some of these stones when, you know, there's no information available to the average gemologist about certain things.
Absolutely, but if somebody asks you, puts a premium on origin, tell them that it is a relevant question to ask, but the first question they should ask is this stone beautiful?
Okay, thank you.
So,
Oh, sorry. Can I ask it?
ladies first.
Sorry. This is more comment to your point about the importance of having the material and doing the research. Very few people are aware that there are some very fine gem quality emeralds from North Carolina. We all associate them with what my father would call garbage. He wouldn't call it garbage because it was a gemstone. But I happened to come into some amazing representatives of the North Carolina emerald. I showed them to Nathan Renfro. Nathan says, could we do research on this? And so I went and I submitted it today so that research will be done by GIA, and it will be the first in-depth gemological research on material from our own country. And I think this was very important, and I just want to say thank you and applaud the GIA for doing it. And I might add, it's for research, so they're not charging for it, which is an incentive to provide it to you. And we can arrange for you to visit the mine, Will, if you would like. Thank you.
All right. That's a great thing. I think I would like to just add a few comments on this as well. As I mentioned before, it is important to go visit the mines, but it is also, it doesn't mean that a sample is not from a mine that is useless for research. And this is a very good example for it. So this would be a sample that we would classify as an F-type sample. So we get it from a secondary source, totally unrelated to the mine. No way of knowing that we connect it. But this sample will still be used for research and will probably later be supplemented with samples that we could get from a mine. But this is a great start already. So thank you very much for offering us the opportunity.
So I just have one last quick question.
Sure.
How often are you offered synthetics or imitations at the actual mine site?
I usually see more synthetics during one field trip than I've done during my whole GG training.
That's what I thought.
All right. All right, thank you very much.
Jim, thank you.